Good morning or good afternoon, as the case may be. My name is Dave Kempisty. I work at Evoqua Water Technologies, where I am the Senior Business Development Manager for Emerging Contaminants. And my quip or lame joke is, how do you spell emerging contaminants? You spell that PFAS. Or at least that's how I feel it is, as I spend a large portion of my time talking about per and polyfluoroalkyl substances, and that's what I'd like to talk to you today about. Their removal from groundwater and talk through 4 different case studies revolving granular activated carbon and ion exchange resin. Regarding a presentation overview, I will touch upon who Evoqua is and who Evoqua is in the PFAS space. Talk really briefly about PFAS, as I feel that this audience is well familiar and well versed on what these substances are. And then I'll talk to some of the treatment options that Evoqua offers, not just a one-size-fits-all treatment solution, but a variety of options underneath the Evoqua umbrella. And in particular, I'll talk about piloting and benchtop capabilities. Specifically talking about, I have 2 slides to share about the rapid small-scale column test, some of the strengths of the RSSCT, but also some of the limitations and how it should not be used. And then we'll get into the case studies, and there are 4 of them. The first talking about the application of granular activated carbon to remove PFAS from water. Excuse me. The second we'll be talking about ion exchange used for that same application. The third talks about a more difficult water matrix, a water with 14 milligrams per liter of total organic carbon, and the use of both granular activated carbon and ion exchange. And the 4th case study that we'll talk about is from Pownal, Vermont, and it is the application of granular activated carbon, as the slide says, but really it's more the application of mobile and rental assets to provide potable water in a sooner rather than later, while the permanent solution is being developed or while the ideal media or technology is being selected. You can still provide and get after clean drinking water today, and so the 4th case study talks to that. An error on the slide: there won't be any time for questions today, as this webinar won't allow that, but perhaps at a later date or with my contact information on the last slide. If there are any questions, please reach out to me and we can talk through things. With regards to who Evoqua is and who we are, here's some numbers that talk to the total number of team members that we have and locations and so forth. But Evoqua, we're a relatively new company. We have a 100-year heritage of treating water and wastewater, demonstrated performance of innovation and expertise in this water treatment world. So we are a spinoff from Siemens Water Technology, where we're owned by came to be owned by a private equity enterprise in 2017, and then we went public. So underneath the Evoqua Water Technologies umbrella, we have a large number of recognizable brands that you may be familiar with. Wallace & Tiernan with their disinfection chlorination solutions. Neptune Benson is another one. They are the official water quality sponsor of USA Swimming. Nexed and their desalination operations. ADI Systems with their industrial wastewater treatment area of application. Delta UV and others. So Evoqua is all over the water space. And in fact, when I first came looking at Evoqua Water Technologies, I was thinking that they were players in terms of water treatment, in terms of wastewater treatment, in terms of environmental remediation. And yes, we do all that, but I needed to expand my aperture to really talk to and understand the markets that they are applicable to. So anything that touches water is an area of opportunity for Evoqua. So that includes mining and manufacturing, hydrocarbon processing industries, the chemical processing industry, microelectronics, food and beverage, pharmaceuticals, power, a whole bunch. So Evoqua is divided into a couple different segments: applied product technologies and integrated solutions and services, where I work. And underneath integrated solutions and services, there are 4 divisions. And that's where we'll find the hydrocarbon processing industry, municipal services, environmental services, and then we can get after and reach out to any PFAS opportunities in any of those vertical markets. This slide is meant to depict who we are, or who we hope to be anyways, in the PFAS space. It talks to the different markets that we touch, those being generally the military market, the industrial market, and the municipal market. But across those segments, from the municipal market, we talk to and interact, do business with private as well as public, big, small, medium, all sizes. We work in the military space. With the military space, we provide treatment to affected drinking water systems. We can focus on remediation aspects of affected aquifers, or with the disposal and handling of volumes of wastewater that's associated with fire training activities. We're also involved in the treatment of wastewater, industrial wastewater, either process water or wastewater from manufacturing processes, be that from primary producers of PFAS or secondary users. We're active in the hydrocarbon processing industry, as well as the larger chemical processing industry. And we have customers that want us to treat their landfill leachate. We service metal plating operations and facilities. So the list goes on. Some of them are smaller, but it makes us very well diversified across the whole sector of industrial applications. So specifically focusing on the viewer's upper right-hand corner, no, that would be the upper left-hand corner, talking about capabilities. This kind of talks to our comprehensive offerings, our value proposition, and offering carbon and resin solutions. Not one solution fits for all applications, but we don't push singularly and solely one treatment technology. We have a variety of carbons and a variety of resins that I'll talk to here in a little bit. But we also offer, as alluded to earlier, emergency and mobile solutions for temporary treatment while the permanent solution is being developed, while the ideal treatment technology is being discovered. That can be alluded to or informed by piloting and bench scale capabilities that we have, modeling capabilities that we have for that matter. We're involved in site remediation activities, pump and treat, wellhead treatment. We have a robust service network, can touch 85% of the populace of the United States within 2 hours. And we have carbon reactivation facilities, 3 of them across the country, as well as many different financing options to include, just solely capital expenditures or rental or rent to own or fixed and variable pricing structures. So we have a variety of them. So the idea is a comprehensive solution that we're trying to offer for PFAS solutions. One slide on PFAS and what these chemicals are. This is my PFAS tree. We'll just touch on that and then we will leave it. See that? I've got a pun in there. Just trying to talk to the dynamic nature of the PFAS space as we know it. Regulations are changing. Analytical limits of detection are being lowered. New toxicological studies are coming forward and demonstrating adverse health effects or different adverse health effects, which are influencing those regulations. And then treatment technologies are being required and destructive technologies are coming to the forefront. Novel adsorbent technologies are coming out. But all of these are advancing, these 4 areas. And I think they're all linked together as like a system of systems. And so it just talks to the complexity of PFAS and talks to the dynamic nature. And so this audience is well versed on per and polyfluoroalkyl substances, but I think it's fascinating that you can pick any of these sort of words off of the word cloud and just kind of digress and see how they're all intertwined and related to one another. And here this shows the state regulatory landscape. And it's important to understand and appreciate that in that the states have been more aggressive and they move much more quickly than the federal regulatory agencies, the EPA in particular. And they come out with their own set of guidances, maximum contaminant levels, response levels, action levels, advisories. So there's these different terms for drinking water, surface water, groundwater. So it's again very dynamic in understanding how that is moving, which states are advancing, what are the new contaminants of concern, and it's not just PFOA and PFAS, but it's a variety of them. So shorter chain versus isomers, not necessarily on the regulatory landscape right now, but there are a variety of activities ongoing. And this map is, this data can be pulled from ITRC, and we have a map that leverages this data, which is updated quarterly, but it's very valuable. Evoqua has over 35 PFAS installations nationwide. 10 of those are leveraging our mobile or rental configurations, assets. And they are diversified across the drinking water, the military, and the industrial segments that we mentioned earlier. So we are a significant player in this space, and we are continuing to grow and expand this nationwide install map. As far as PFAS treatment options, and there are a variety of them, but by and large, the two that we promote most are granular activated carbon and single pass ion exchange resin. But I will say that Evoqua, as a larger water treatment company, has a variety of technologies, and if there were applications for water reuse or direct potable reuse, targeting short chain removals of PFAS and membranes, for instance, were required, we have that capability to reach across the aisle to the heavy industry brothers inside Evoqua Water Technology and get membranes or acquire membranes and do the design and understand the limitations and so forth. But again, back to granular activated carbon and ion exchange, those are the two predominant technologies that we offer. With that, granular activated carbon named best available technology by EPA for organic contaminant removal. It's been around a long time. So the Sanskrit text written from 2000 BC, store your water in copper vessels, expose it to sunlight, and filter through charcoal. So this was said 2,000 years ago. We've been treating water in this manner for a long time. By we, I mean humanity, not Evoqua Water Technologies. We don't go back that far, but great for the removal of other organic contaminants if you have co-contaminants. Maybe not as good as if you have organic contaminant, total organic carbon concentrations that you're concerned with. The spent carbon can be reactivated. There are savings there both monetarily as well as sustainably. And minimal maintenance. It's not a terribly complicated process. We have a variety of these products. We have over 30 activated carbons, one of which is an enhanced coconut product. And so the enhanced coconut product has the microporosity, giving it great capacity for some of these contaminants. But the enhancement focuses on the mesoporosity, which allows the kinetics to be increased to that similar to a bituminous carbon. So you're getting both the bang and the buck. I'm not sure that makes sense, but you're getting both desirable properties, advantageous kinetics, and superior kinetics with the enhanced coconut product. Got a couple of ultra-carb products on there as well. I'll just note on the second one there, that's the low density product. So oftentimes you'll find 20,000 pounds as the designated weight for some of these vessels. But if you use a low density product, you can get away with 16,700 pounds of a LD product sold by pound. That's going to result in some savings. And these products compete well with our competitors and in both cost and performance. For the ion exchange option, lower empty bed contact times compared to carbon, smaller footprints, no additional chemicals or liquid waste that you have to consider or treat. That would not be applicable if you were looking at regeneration of the ion exchange resin. And the spent resin can be incinerated, and it's another minimal maintenance, and it's accepted, and it's growing in acceptance. So we offer a variety of resins, 2 of which are listed here, but the PSR2 Plus competes with all of our competitors and sometimes outperforms and sometimes does not outperform. And that's kind of one of the takeaway messages of this webinar, is that each site has unique water and unique characteristics and unique co-contaminants and a different total organic carbon, both concentration and characterization. There are different nuances with each site, and it can result in different performance. So you're not going to find one winner that is the superior performer each and every time. This slide shows our pilot testing capability, and then this leads into the 2 RSSCT slides that I wanted to share with you. But this is a picture of the largest pilot built recently or to date, or it is 8 granular activated carbons, 4 ion exchange resins, and 2 novel adsorbents, and this is being used or employed at OCWD, Orange County Water District, to determine the superior performing media, not just performance, but also looking at cost, to determine which is the best product or technology to employ for removing these compounds from their drinking water. Additionally, this is the pilot, but we can also offer those rapid small-scale column tests, which allow you to receive information with a fraction of the water, with a fraction of the samples, in a fraction of the time. Really, that's the savings in time, to identify superior performers from the media side. These next 2 slides talk to the rapid small-scale column test and what the small-scale column test can and cannot do. So on this first slide, let me just talk about my axes first. On the x-axis, you have the throughput measured in bed volumes, while the y-axis talks about the normalized perfluoroalkyl acid concentration, effluent concentration over influent concentration. And the contaminants we're looking at are 3 different perfluoroalkyl acids, and they are in a surface water, that's from North Carolina, denoted NC, and from a groundwater from Minnesota, denoted MN. And what we see is this RSSCT effectively describing the breakthrough curves that we would see in a full-scale treatment system. And so what do we see? You see shorter chain compounds breaking through before longer chain compounds. A 6-compound HXA breaking through before the 8-compound PFOA. You also see the sulfonic acid containing PFAS breaking through after the carboxylic containing PFAS. And finally, we see the surface water breaking through much before. The surface water is the solid lines breaking through much before the dashed lines. And that's because of the higher total organic carbon in the surface water, taking up, outcompeting the PFAS contaminants for sorption sites on the granular activated carbon. This is what RSSCTs are good for. They allow you to effectively describe breakthrough curves that you'll see similar trends in the full-scale system. This might be what RSSCTs, you're trying to stretch their capability. Viewers upper right-hand side, you're seeing the Minnesota groundwater for 3 different perfluoroalkyl acids. Bottom left is the North Carolina surface water. The top right, the RSSCT treating the Minnesota groundwater, this one consistently over-predicted the full-scale adsorber performance. So the arithmetic, is that the word I'm looking for? The arithmetic mean of this over-prediction is around, for all data is not shown here, but for the 6 PFAAs that we did, averaged around 70% over-prediction for the RSSCT. So poor blockage is your strongest leading working hypothesis to define this result, or to explain this result. Full-scale absorbers use granular activated carbon of a larger size than the RSSCT. So if and when dissolved organic matter absorbs near the exterior of the granular activated carbon surface, the fraction of the surface area that becomes unavailable for absorption of the target organic, that increases with increasing GAC size. And so the greater capacity reduction is seen with larger granular activated carbon size, if that makes any sense. So that's what I'm saying is the larger granular activated carbon has greater fouling, and therefore rapid small scale column tests using the smaller GAC size, this one was 100 by 200 mesh, has a greater capacity and greater performance. That's what we expect to see. The bottom left-hand side, comparing to the groundwater scenario there, is the surface water. And so the pilot scale breakthrough and the RSSCT matched much more closely. The bed volumes treated to 10 and 50% were very similar for the RSSCT and the pilot scale. So this result looks promising, but it's most likely fortuitous because the TOC concentrations in the grab sample used for the RSSCT had, I think it was around 35% higher TOC than the concentration in the coagulated surface water. So the differences in TOC is believed to account for a lot of this similar breakthrough. There was some difference in, again, the characteristic of the TOC as well. But this is where I think the takeaway for these last two slides is really how to use the RSSCT effectively. If you want to predict adsorbent A performing better than adsorbent B and it proves out that way in an RSSCT, it'll probably will prove out that way in a full-scale adsorber. If you want to say you see 55,000 bed volumes in your RSSCT and you expect to see 55,000 bed volumes in your full-scale system, that might be taking it and stretching it a little too far, the bridge too far. There are scaling factors that can be applied to this. So I'm not saying it can't be done, but it just takes a little bit more effort. You need to have a full scale or a pilot scale and one RSSCT to establish what that scaling factor is. And then you can do RSSCTs all along to arrive at what you're trying to see for full scale performance. But it's only good for that aquifer, and because each water is unique and different. All right, case studies. This first one talks about Kennebunkport, Kennebunk, and Wells Water District. And PFOA and PFAS were found in the source well, and it was unknown what their contribution was. It was later found out to be from an agricultural runoff source that included biosolids deposited there from a municipal wastewater treatment plant. And they were receiving contributions at that wastewater treatment plant from contributions from a local paper mill. Concentrations at Kennebunk and Kennebunkport and Wells Water District were below the EPA health advisory, but they wanted to shut down the well and receive some treatment. And so they consulted with Evoqua, and we advised them to pilot test several types of carbon to determine, again, which one performed best. The results showed Evoqua's carbon made from coconut provided an additional runtime, 3 months of runtime versus the other carbons. And so they went ahead and installed a full-scale high-pressure vessel system to remove the PFAS from their water. And here are the results that support their decision from the pilot investigation. And so the x-axis is the throughput in bed volumes, and as a refresher, bed volumes is synonymous with actual volume of water treated, as long as your bed volumes are the same in size. If your bed volumes are different, word of warning, say between an ion exchange application and a granular activated carbon application, then you would want to use a different specific throughput variable like gallons of water treated to be more of an apples to apples comparison. Anyways, in this case, the bed volumes are the same, and so the comparison's valid. The y-axis here is the PFOA concentration in parts per trillion, and the influent is shown here as 10 parts per trillion, and the breakthrough profiles for each of the different medias is presented. The different medias, there were 4 of them, 4 carbons, and not just testing Evoqua products, but we looked at our competitors' 12 by 40 bituminous product. We looked at Evoqua's coconut product, our enhanced coconut, as well as our CX reactivated product. And you can see from the pilot results that the Evoqua AC1230CX, that product performed the best. So 2 things here. This doesn't always happen. Sometimes the competitor's product performs better, and in that case, a further look at the economics has to be considered. I mean, perhaps it performs 10% better, but it costs 25% more. However, solution-oriented means solution-oriented, and so if that means not using an Evoqua media, then you have to be cognizant of the customer and try to understand and appreciate what they're trying to get after, which is lowering their cost. And again, if you're looking at treating this aquifer for years on end, a superior performing product is advantageous for a lot of different reasons. And at the same time, I didn't mention this part earlier, and I should have. Our vessels are multimedia ready. And so we offer the SEPTA bottom design for our tanks, and that allows slot screening to be changed out as appropriate to accommodate either resin or carbon, or say a novel adsorbent that comes to the forefront in the future. All of that can be used in the same vessel. So in this way, you're not committed to a particular technology due to a capital investment. New novel media is identified, you can use it. Ion exchange makes more sense later on, you can switch. So for the Kennebunkport case study, they ended up going with a single 12-foot diameter sand filter vessel, followed by one lead lag granular activated carbon system using the enhanced coconut product, the AquaCarb 1230CX. They had an empty bed contact time of around 10 minutes. It was installed outdoor. There was a custom segregation and react implemented for this, so they can save, again, significant savings, up to 30% on carbon rebeds. And as I talked to just recently on the previous slide, the SEPTA design allows for built-in flexibility associated with future technologies. And with this SEPTA design, this is back to recent conversations in February of 2020. Recently, we went to San Gabriel's site, the B5 plant, and tried to understand. They have both our competitors' vessels and our vessels, and visited with the site, the treatment superintendent, and asked him for his opinion on the preferred vessels for ease of use, ease of maintenance. And hands down, the operator said, buy these Evoqua, these vessels, the Evoqua vessels. They are the better lot. So the main reason given for this was the reduced pressure drop experienced through the Evoqua vessels, and therefore the lower pumping costs. He also cited increased maintenance requirements, primarily replacing broken nozzles, replacing blown out gaskets, and so forth, due to the higher pressures associated with the competitors' vessels. So in the end, the impact to the ratepayers is roughly 3 to 4 cents per day. Our goal is now to continually produce drinking water with non-detect levels, said the Kennebunkport superintendent. With Evoqua's lead lag system, we should have no problem doing that. The second case study I wanted to talk about with you today is in Stratmoor Hills in Colorado Springs, Colorado. And this is near and dear to my heart, as this is where I live and am talking to you from right now. Stratmoor Hills, their aquifer, they receive drinking water from the Widefield aquifer. Peterson Air Force Base was implicated in contaminating the Widefield aquifer, which serves 4 different communities: Fountain, Security, Stratmoor Hills, and Widefield. And Stratmoor Hills identified these 3 PFAS components in their water and wanted to remove those, obviously. However, in this case, they didn't have time for a pilot scale or a pilot test to be completed, or for that matter, RSSCTs. They wanted to move directly to treatment due to some funding constraints and timelines associated with receiving funding. They wanted to put treatment online as soon as possible, which they did, but we used and leveraged a different site's RSSCTs and piloting data to determine the optimal treatment technology. Here you can see the breakthrough curves for the legally borrowed pilot data that we had from a nearby municipality using the same aquifer, but just with higher PFAS loads. And so this identified a superior performer or an effective ion exchange resin, that being the PSR2+ resin. Again, bed volumes on the x-axis, nanograms per liter this time on the y-axis, and you can see some breakthrough for PFOA just after 70,000 bed volumes, and for the heptanoic carboxylate, viewer's bottom left, around 50,000 bed volumes. And so in the end, the configuration or the treatment that was selected, the final system involved pre-filters, 2 lead lag trains, smaller in nature, the IEX 48, which are the 4-foot diameter vessels containing 60 cubic feet of the PSR2 plus resin per vessel, and treats around 300 gallons per minute. It works in the summertime at an empty bed contact time of 2.6 minutes. I mentioned the summertime because that's when they have increased demand and have to use the wide field aquifer. In the wintertime, they have an alternative water source, and they store the vessels indoors. They move them indoors. Quickly and safely installed processes. I said around 300 gallons per minute. Here we're claiming 350. It's been fantastic ever since it went online, says the district manager of Stratmoor Hills. Pretty much non-existent PFAS levels. This third case study is talking about a more challenging water, and this is associated with a site in the southeastern portion of the United States. 8 million gallons per day. The contamination, unknown confirmed source of contamination, but thought to be due to firefighting foams at a nearby location. The influent concentrations were greater than the Environmental Protection Agency's lifetime health advisory, and the opportunity was brought to us by a relationship with an A&E firm, so we're always interested in partnering with and collaborating with engineering firms to move together collaboratively in this space. This was the challenging water I mentioned at the beginning of the presentation and was 14 parts per million. And they wanted to remove things down PFAS-wise down to less than 10 parts per trillion. So we developed a pilot, tested both granular activated carbon and ion exchange. Now, due to the results of the first pilot that the granular activated carbon and the higher total organic carbon, 14 parts per million, was not an effective treatment solution for this particular water. However, the ion exchange, although it turned black within 24 hours and didn't look quite so pretty, was quite effective at removing the PFAS as demonstrated on this diagram here. Throughput on the x-axis, concentration out the effluent over the concentration in the influent on the y-axis. And so you can see that after 150,000 bed volumes, PFAS and the PFHXS were at no detect, non-detect. So we moved to a full-scale comparison with a variety of different ion exchange resins with different configurations and using not just the Evoqua products, but our competitors. And here you can see the results of the full-scale comparison of the 4 different resins. And so on the graph or the figure, you can see the x-axis. We've actually changed the x-axis to specific throughput in millions of gallons of water treated because we no longer have equal size bed volumes. So the bed volume comparison isn't as legitimate, but a specific throughput would be a more accurate way to look at these different treatment configurations. And on the y-axis, we've got the nanograms per liter of the PFOA and the PFAS as they break through. And you can see that each treatment configuration, the vendors were allowed to select whatever treatment configuration they thought would result in optimal removal of the target organic. And so 2 of the vendors selected a carbon-resin combination, while 1 of the vendors selected a resin-resin combination. And then Evoqua, we thought singularly the PSR2 Plus would be able to handle the high organics as well as the target contaminant, remove the target contaminant of PFOA and PFAS. And here you can see the superior performer is Evoqua's configuration with that 150 approaching 175 million gallons of water treated. There is still yet to be breakthrough of PFOA or PFOS. So again, ideally we're looking at a greater throughput, and then you'd compare your cost of these media fills to understand what the optimal treatment configuration is And in this case, you're getting the greatest millions of gallons of water treated with just the singular PSR2 plus resin. Finally, this fourth case study is talking about the emergency treatment in Pownal, Vermont. And again, I talked to this in the beginning. The idea being that we were able to procure or get treatment on site within, I think it was within 2 weeks, to establish and get after providing drinking water, emergency relief, temporary treatment, while the full-scale solution is being identified, funded, designed, delivered, all of it. And it makes the most sense to try to identify what the ideal solution is, but sometimes you can't wait. And so the idea would be to leverage these mobile assets and use this capability to get after a clean make water date right now. And whether or not that's potable applications, that certainly would work for, but it's also applicable to the industrial process water or wastewater. It's also applicable to construction dewatering activities, emergency response, temporary and semi-permanent connections. This came about in 2017 when Evoqua Water Technologies procured Proact Environmental Solutions, and this was one of their strengths. Now one of our strengths is to be able to provide this mobile fleet, or offer this mobile fleet for these types of applications. So finally, last slide, talking to we customize a solution for your community based upon local water needs. They're all different. There's not one particular solution that we push in each and every situation, be it resin, be it carbon. As we said earlier, if it's resins, if it's membranes, we can identify how to get those and how to design those. We have that in Evoqua Water Technologies. Our portfolio is unbiased, technology agnostic, but solution driven. So we try to provide a full variety of options. We talked about the low density granular activated carbon. We talked about the enhanced coconut product. We talked about the SEPTA vessel design, fast deployment for the emergency response, as well as the laboratory support, being the piloting or RSSCTs or modeling, as well as the reactivation services and the service network that supports that. So it's trying to position ourselves as this comprehensive solution provider to provide the customer with the best solution in the most timely fashion at the lowest price to meet their desired expectations. Guys, that's the last, or this I guess is the last slide of the presentation. We're right at 37 minutes on the button. Andrew told me to go 35 to 40 minutes, so I hope it was informative. There's contact information on here for both myself and my colleague Caitlin Beretta. Please reach out to us to talk about PFAS, talk about emerging contaminants. Phone numbers are there. I hope you enjoyed it and look forward to working with you or hearing from you down the line. Thank you very much.